Hello everyone. In this lecture, we will learn about 16-bit microprocessor 8086. In our previous lectures, we have learned about 8085, which is a 8-bit microprocessor. And today we will discuss about 16-bit microprocessor, which is 8086. Now, first of all, this is an introduction. 8086 microprocessor is an enhanced version of 8085. Basically, when an evolution is happened, then obviously the version which is coming or which is modernized, it enhances the some features. That's why 8086 microprocessor is an enhanced version of 8085 microprocessor. Was designed by Intel in 1976. It is a 16-bit microprocessor having 20 address lines and 16 data lines. Means as it is 16-bit microprocessor, so it has 16-bit data bus. Whereas in 8085 the data bus is 8-bit and address bus was 16-bit. Here data bus is 16-bit and address bus is of 20 bits, and it provides up to 1 MB storage. It consists of powerful instruction set which provides operations like multiplication and division easily. Now it supports two modes of operation. One is maximum mode and second one is minimum mode. What is maximum mode? Maximum mode is suitable for system having multiple processors, and minimum mode is suitable for system having a single processor. Now some features of 8086. First of all, most prominent features like it has an instruction queue which is capable of storing 6 instruction bytes from the memory, resulting in faster processing. It was the fast 16-bit processor having 16-bit ALU, 16-bit registers, internal data bus and 16-bit external data bus, resulting in faster processing. Okay, there is three versions based on the frequency. One is 8086, which is 5 megahertz. Second one is 80862, which is 8 megahertz. And last one is C80861, which is 10 megahertz frequency. It uses two stages of pipelining. One is fetching stage and second one is executing stage, which improves performance. Fetch stage can prefetch up to 6 bytes of instructions and stores them in a queue. Execution stage executes these instructions, which is already fetched by the microprocessor. It has 256 vectored interrupts. It consists of 29,000 transistors. Now, the comparison between 8085 and 8086 microprocessor, which is very important question in this syllabus, and you can see that in every alternative year the question had come. Okay, now first of all, the size. 8085 is 8-bit microprocessor, whereas 8086 is 16-bit microprocessor. Already I have told it. After that, address bus. 16-bit address bus for 8085 and in 8086 20-bit. For memory, 8085 64 KB, 8086 1 MB. instruction. 8085 doesn't have any instruction queue, whereas 8086 has an instruction queue. Pipelining. 8085 doesn't support a pipelined architecture while 8086 supports. I/O. 8085 can address 2 to the power 8 means 256 IOs, whereas 8086 can access 2 to the power 16 means 65,536 IOs. It is a huge amount. And last point is cost. This is a very important point. The cost of 8085 is low, whereas 8086 is very high. Okay, now architecture of 8086. First of all, we can see that two units are there. One is BIU means bus interface unit, and second one is EU means execution unit. Memory interface. After that, by A bus, B bus and C bus, the information has come to the instruction stream byte queue, means this is the instruction queue, which I have told earlier that 8086 has an instruction queue but 8085 has not. Okay. Then you can see ES, CS, SS, DS, IP. These are the segment registers. ES means extra segment, CS means code segment, SS means stack segment, DS means data segment, and IP means instruction pointer, which I will explain in the later slides. Okay, and in execution unit you can see that AH, BH, CH, DH, and besides of this AL, BL, CL, DL. These are all the registers. After that SP, BP, SI, DI. And here also one arithmetic logic unit, means ALU is there. Some operands and flag registers are also there, like 8085. Now, which we have already seen in our previous slides, the architecture. Now we will explain these functional units. First of all, I have already told that EU means execution unit, BIU means bus interface unit. First, EU. Execution unit gives instructions to BIU stating from where to fetch the data and then decode and execute those instructions. Its function is to control operations on data using the instruction decoder and ALU. Execution unit has no direct connection with system buses. We can see that execution unit doesn't have any direct connection with the internal buses. No direct connection. Okay. Now it performs operations over data through BIU. As it has no direct connection with the internal buses, so it performs operations over data through BIU. Okay, now some functional units we will discuss. First of all, ALU. We all know about that it handles all arithmetic and logical operations like plus, minus, division, multiplication, or and not operations. Flag registers. 16-bit register. Like a flip-flop, it changes the status according to the result stored in the accumulator. 9 flags in 8086, whereas 5 flags were in 8085. This is one of the comparison. They are divided into two groups, conditional flags and control flags. First of all, conditional flags. In conditional flags, it represents the result of the last arithmetic or logical instruction executed. First of all, carry flag. This indicates an overflow condition for arithmetic operations. Auxiliary flag. When an operation is performed at ALU, it results in a carry or borrow from lower nibble, that is D0 to D3, to upper nibble, that is D4 to D7. Total D0 to D7 means 8 bit. Then this flag is set, that is carry given by D3 bit to D4 is AF flag. The processor uses this flag to perform binary to BCD conversion. Now parity flag. This flag is used to indicate the parity of the result. Parity flag is also in 8085 also. I have told my in previous lecture of 8085. That is, when the lower order 8 bits of the result contains even number of ones, then the parity flag is set. For odd number of ones, parity flag is reset. Zero flag. This flag is set to 1 when the result of arithmetic or logical operation is 0. Else it is set to 0. Sign flag. This flag holds the sign of the result. That is, when the result of the operation is negative, then the sign flag is set to 1. Otherwise, it will be 0. Overflow flag. This flag represents the result when the system capacity is exceeded. Overflow means it exceeds. So, when this flag will indicate that result when the system capacity is exceeded. Now control flags. In the unit of control flags, one is trap flag. Trap means it is used for single step control and allows the user to execute one instruction at a time for debugging. If it is set, then the program can be run in a single step mode. Interrupt flag. It is an interrupt enable or disable flag that is used to allow or prohibit the interruption of a program. If it is set 1 for interrupt enabled condition and set to 0 for interrupt disabled condition. Direction flag. It is used in string operation. As the name suggests, when it is set, then string bytes are accessed from the higher memory address to the lower memory address, and vice versa, means when it is reset, then lower to higher. Now some general purpose registers. There are 8 general purpose registers, that is H, L, BH, BL, CL, CH, DH and DL. These registers can be used individually to store 8-bit data, but it can be used in pairs to store 16-bit data. The valid register pairs are H, L, BH, BL, CH, CL, DH and DL, and it is referred like H and L combined AX, BH and BL combined BX. Okay. Now AX register. It is also known as accumulator register. It is used to store operands for arithmetic operations. Now BX. This is a base register. It is used to store starting base address of the memory area within the data segment. After that CX. It is referred to as counter, means it is used in loop instruction to store the loop counter. Counter means 0, 1, 2, 3, it will count. After that DX register. This register is used to hold IO port address, means input output port, for IO instruction. After that stack pointer register. It is also 16-bit register which holds the address from the start of the segment to the memory location where a word was most recently stored on the stack. Okay, then bus interface unit, BIU. Basically, BIU takes care of all data and addresses transfers on the buses for the EU, like sending addresses, fetching instructions from the memory, reading data from the ports and the memory, as well as writing data to the ports and the memory. EU has no direction with the internal buses. So this is possible with the BIU. EU and BIU are connected with the internal buses. Only EU is connected with the internal buses through BIU. So EU and BIU is connected through the internal buses. I think it is clear to you. Now it has some functional parts. First of all, instruction queue. BIU contains the instruction queue. BIU gets the up to 6 bytes of next instructions and stores them in the instruction queue. If we can see in the architecture, we can see this 1 to 6. This 1 to 6 instruction queue. Now it stores them in the instruction queue. Okay, then when EU executes instructions and is ready for its next instruction, then it simply reads the instruction from this instruction queue, resulting in increased execution speed. Fetching the next instruction while the current instruction executes is called pipelining. Means I am here for the current instruction, and for this situation we are fetching the next instruction also. This called pipelining, means it already kept in the line. Segment registers. BIU has 4 segment buses: CS, DS, SS and ES. It holds the addresses of instructions and data in memory, which are used by the processor to access memory locations. It also contains one pointer register, IP, instruction pointer, which holds the address of the next instruction to be executed by the EU. CS means code segment. It is used for addressing a memory location in the code segment of the memory where the executable program is stored. Then DS means data segment. It consists of data used by the program, and this accessed in the data segment by an offset address or the content of other register that holds the offset address. After that, stack segment, it handles memory to store data and addressing during execution. After that, ES means extra segment. ES is additional data segment. As the name suggests, it is an additional data segment which is used by the string to hold the extra destination data. After that, instruction pointer, it is a 16-bit register used to hold the address of the next instruction to be executed, already which we have said earlier. Thank you for listening this lecture. Please subscribe our channel, and in the next lecture we will discuss about the 8086 next parts. Thank you.